Good day, I'm Vince Joel J. Alvarez, and for today's video, I'm going to create the T implementation of the shift registers SISO, SIPO, PISO, and PIPO. So first, which is the SISO, which is the serial in, serial out. First, we are going to need one input pin, one clock, which you can also find at the wiring, 4D flip-flops, 4D flip-flops, which you can find at the memory, and one LED lights because one LED lights as the output, and using the SISO or in creating the SISO, which is a serial in, serial out, because serial in, serial out, which is the SISO, have one input and would have a one output. So in creating this, we also need the button. So in creating this circuit, we just need to connect this by the wire. You need to connect the D flip-flops, the Q from the D, as you can see, at the circuit. So after this, you have to connect this to the clock. And lastly, you need to connect this wirings, enable for it to work as a unit, the circuit. So to check if the circuit is properly working, we need to press the poke button, put an input, and turn on the clock. Once the clock is open, you can see it will have an output at the D flip-flop first. And when you click it the second time, the output would be at the second flip-flop. Third, fourth, fourth, which is the last D flip-flop, you can see the output at the LED, which will consider the LED to glow. So after this, we are going to create the SIPO, which is the serial in, parallel out. In SIPO, we will need an input pin for the flip-flops as well. Four LED lights. And a one clock. So just like how we have connected the serial in, serial out, it's the same, but it will have no button in it because it has a four outputs. It will have an output on each D flip-flop. Just connect this by the wires. So to check if it's properly working, again, we will need the poke button, put an input in it, and to turn on the flip-flops, we are going to press the clock. So as you can see, when you press the clock once, the first output, or which is the LED, would light up. The second LED would light up if you press it twice, thrice, the third, then the fourth one. So we are done with the first two circuits, which is the serial in, serial out, and the serial in, parallel out register, 4-bit register. So the third one would be the PISO. I forgot to mention that the SISO, we have the button in order for us to reset the circuit. So as we continue, the third circuit would be the PISO, or the parallel in, serial out shift register. So in creating this, you're going to need an one input pin and six AND gates, which would be facing south. And a 3 OR gate in order for us to connect the AND gates. So after this, we are going to need 4 more input pins at the top. So we could never call it a shift register if it will not have the flip-flops. So we are going to need 4D flip-flops as well. And a clock, one clock, and one shift, and one button to reset the circuit, as well as the LED light, which will give us the output of the whole circuit. So we need to connect this one by one. Oh, first input pin would also need the NOT gate as well. Forget about that. So here you go. We just need to connect this one by one. So this is the circuit that we are going to came up with the PISO, which is the parallel in serial out shifter. So enable for us to check. Earlier, some of my connections were wrong, so I have created and cleaned it, enable for us to have a properly working circuit. So in checking this, we need to first reset this. So I had inputted 101 in the circuit. So enable for us to see if it is working, we need to press the clock once. So as you can see, the D flip-flops would have the value that I had inputted in the circuit, which is 101. So enable for us to have a shift load, we need to first press this, which is the first input pin that we had put. So in checking if the shift load inside the circuit would flow, we need to press the clock twice. So as you can see, the flip-flops output had been 1101, which will lead to a 1 or a glowing LED light. So in pressing it again, the clock, the D flip-flop had been 1110, which would end up on 0 or a not glowing LED light. So after this, lastly, the circuit that we have to create, which is the PIPO. Lastly, the circuit that we need to create, which is the parallel in, parallel out. We are going to need five, I have pins, four input pins, 4D flip-flops, 4D flip-flops that you could see in the memory, and four LED lights, which would have the output of the circuit that we had created. D, and it would not be a shift registers if we don't have the clock. So after this, we just need to connect this with each other. So this is the circuit that we are going to come up with on the PIPO, which is the parallel out 4-bit shift register. So enable for us to check if it's properly working. I'm going to put an input in it, and as you can see, I have inputted. So to check if it would have the output, which is the same input that I have inputted because it is a parallel in, parallel out circuit. So we need to press this. So as you can see, it lights up in a order which I had inputted the input values and the D flip-flops. So to change, to see if it's properly working. So the circuits that we have created is properly working and would complement or implement all the things that the SISO, SIPO, PISO, and PIPO implementation on the key implementation as a shift register. That's all. Thank you.